Hello and welcome to the generator effect revision video from scienceworksheets.co.uk. Please like, subscribe and comment to support the channel. The generator effect is a term used to explain an induced potential difference across the ends of a conductor, such as a wire, when an electrical conductor moves relative to a magnetic field. So this could be moving a wire through a magnetic field or a magnet through a coil of wire. Alternatively, it can be when there is a change in the magnetic field around a conductor, and this would occur when you move a magnet through a coil of wire. An electrical conductor moving relative to the magnetic field. So in this case, the black wire is being moved up and down through the magnetic field, and the wire will cut these blue magnetic field lines, which will induce a potential difference across the ends of the wire. If the wire is part of a complete circuit, which it is here, then a current will flow, and if the direction of the wire is reversed, then the direction of the current reverses. Another example of an electrical conductor moving relative to the magnetic field is when a bar magnet moves in and out of the coil of wire, and as the bar magnet moves through the coil of wire cuts the magnetic field lines around the magnet, and a potential difference is induced across the ends of the wire. And if the wire is part of a complete circuit, which it is here, then a current will flow, and if the direction of the magnet is reversed, then the direction of the current reverses. A change in the magnetic field around the conductor. When a magnet is moved in and out of the coil of wire, a change in the magnetic field around the wire occurs. Pushing the magnet into the coil. When a magnet is pushed into the coil, the magnetic field inside the coil increases, and that change in magnetic field induces a potential difference across the ends of the coil. If the coil is part of a complete circuit, this potential difference causes a current to flow. Pulling the magnet out of the coil. When a magnet is pulled out of the coil, the magnetic field inside the coil decreases. That change in magnetic field induces a potential difference across the ends of the coil, and if the coil is part of a complete circuit, this potential difference causes a current to flow. Factors that affect the size of the induced potential difference or current. The faster the movement of the conductor or magnet, the greater the rate of change in the magnetic field, which increases the size of the induced potential difference or current. A stronger magnetic field produces a larger induced voltage because there's more magnetic field lines are being cut. And the more turns or loops of wire, then the more area for the magnetic field to pass through, and if there are more turns, then there is a greater induced potential difference or current. The longer the wire exposed to the magnetic field, the more field lines are cut, so the greater the induced potential difference or current, and the maximum potential difference is induced when the wire cuts the magnetic field at 90 degrees, so it's perpendicular. If the wire moves parallel to the field, no potential difference is induced. Thank you for watching. See our revision notes, practice questions, link is in the description.